Hello there! In today's video, we will talk about the formula used by scammers in fair games of chance in which many of us have lost money. We will show you very powerful results, and we hope that this video will show the power of understanding mathematics in its pure essence. We are team number 3, made up of Edson Martinez, Lily Perez, Pau Zamora, Erika Villalpando, and myself, Rosangel Medrano. First, let's talk about how scammers work. Imagine you're coming out of a shopping mall, of shopping in a Mexican mall, and a stranger invites you to participate in a board game where you can win some very attractive prizes. If you agree to participate, they explain to you that your goal as player is to score 28 points, but if you miss, 1 point is deducted, and that each shot will cost you a certain amount of money. In this case, let's say 25 Mexican pesos. If when you roll the dice, the sum of the dice faces is marked with a star, you get 5 points. If the sum is marked by a circle, you get 3 points. And so on until you have collected the 48 points, 28 points. Sounds easy, right? Because even when you fail, you only get 1 point deducted. Easy peasy. Well, let me tell you that after a number of attempts, you will realize that you haven't moved at all. And this makes you annoyed and you don't want to play anymore. The stranger who invites you to participate observes you, and in order to encourage you to continue playing, he increases the price and removes the penalty of 1 point. On one condition, that you pay more than the agreed 25 pesos. You continue to play, and you realize that the situation is the same and you can't play anymore because you have lost a lot of money. It is a very sad reality because many people believe that it is possible to win this game, but it is not. And now we will explain it in the best way we know using probability and mathematics. Here's a flowchart that explains the very same of what I have said. If you want to take a look at it, just pause the video all the time you need.
The model of the problem above will use the convolution formula. But first of all, what is the convolution formula? It is an integral that expresses the amount of overlap of function g as it is shifted over another function f. In other words, it blends one function with another. Knowing this, if we have two fair dice independent of each other, it is enough for us to be able to think of combinations in which the sum is equal to 5, such as 1 and 4, 3 and 2, 2 and 3, and 4 and 1. Using the multiplications rule and the independence between dices, we can conclude that the probability for two dice is 4 over 36. For better understanding, let's look at the following picture. There are 4 possible combinations in order that the sum of both dice is 5. So the probability to get a 1 in the first dice is 1 over 6. And to get 4 in the second dice is also 1 over 6. The product of both probabilities is 1 over 36. The same goes for the other 3 combinations. To complete the formula, you will add the final column. So the result is 4 over 36.
The general result to which this exercise refers is central to the theory of the probabilities. So now let us give a quick explanation about what the central limit theorem states. It states that if you have a population of mean mu and a standard deviation of sigma, and take a sufficiently large random samples from the population with a replacement annotation indicator, then the distribution of the sample means will be approximately normally distributed.
Let's check the Excel sheet so we can get more into what we have been talking about.
Now, we will use Microsoft Excel to implement the method known as convolution of two independent random variables. In columns A and C, we type the possible outcomes of rolling two dice, and in column B and D, the probability of obtaining each result, which is, as you can see, in all cases, 1/6. In column F, we write the possible outcomes of the sum, 1 to 12, and in column G, we compute the probability of getting that sum. So the probability of getting a sum of 1 when we roll 2 dice is 0. The probability of getting a sum of 2 is given by the product of the probabilities of getting a 1 in each die, as you can see here. Now, to take on the probability that the sum of the dice is 3, we write a particular case of the so-called convolution formula, that it's right here. Okay, this means the probability that x1, that means die 1, plus x2, which is die 2, equals 3, is equal to the product of the probabilities that x1 equals 1 and x2 equals 2, plus the product of the probabilities that x1 equals 2 and x2 equals 1. Now, in order to complete the remaining entries of the table, we will use the programming capabilities built in Microsoft Excel to implement a formula that does this work for us. So we go to Visual Basic and we insert a new module. This is the code that is going to be required. This formula can be used to calculate each probability we mentioned before. Okay, so range 1 and range 2 are a couple of two-dimensional arrays where the entries of the first column represent the values in the support of each random variable, and the entries of the second column represent the corresponding probabilities. Now we can use the formula we just created, called combo, to obtain these probabilities. Now we proceed to insert an histogram to show the probability masses of the sum of the outcomes of the 2 dice. To obtain it, we use the entries of this range here. Okay, so the convolution procedure has the characteristic of being recursive. This means that it's possible to use it together with the mass function of the sum of 2 dice to calculate the mass function of the sum of 4 dice. Now, to do this, we use column O to label the possible sums of the outcomes of such 4 dice, and use again our function combo, as you can see here. Now, the biggest sum here is 24, in case the 4 dice land on 6, and the probability of getting a sum of 1, 2, and 3 is 0. Now we generate another histogram with these results. Now we repeat the same procedure for the case of 8 dice. That is column X. And we generate another histogram. Now, as you can see, these 2 histograms have the shape of a bell. With these procedures in mind, it is very simple to compute the distribution of the sum of the outcomes of, for example, 10 dice, like here. We just need to apply the convolution procedure to the distributions of the sums of 8 and 2 dice, like this. Now, as in the cases of the last 2 histograms, this plot has the shape of a bell again. For the swindlers of the shopping center, it is enough to notice about the fact that the numbers that allow the player to obtain points are located at the tails of the distribution shown here. Indeed, according to the board, only the squares marked with the numbers from 8 to 21 and those from 35 to 48 allow the player to add points. We can see that the probability of obtaining these numbers is about 18.13%. This means that nearly 18 out of 100 rolls of the dice are lucky. However, the graphic shows that the probability that the sum of the outcomes of 8 dice equals 28 is above 8%. This yells that for almost 2 lucky rolls, the player should expect to double her bets. What we are saying is that losing in this game is not a matter of bad luck, but a well-thought scam.
Now we are going to talk about the central limit theorem. First, we have to remember what the central limit theorem is all about. Let x1, x2 to xn be a sequence of independent and identically distributed random variables with common mean mu and finite variance sigma squared greater than 0. And let Sn defined as the sum of the xi ranging from 1 to n. Here it is. Then we have that the probability that Sn is less than or equal to x is defined by the following expression. For x from minus infinity to infinity as n to infinity. Now we return to the calculations. For this, we use the column C2 to input the following. For this, we use the function distur.norm. The x will be the cell A2. The mean will be multiply 8 by 3.5 and the standard deviation as follows, as shown in the formula. And finally, in the accumulated parameter, we insert a 0. It is worth to mention here that the fact, since each die follows the so-called discrete uniform distribution with parameters 1 and 6, we have that mu is equal to 3.5 and sigma is equal to 2.91. Then we do the same for the 10 dice. Here are the results. And if we observe, here we have the histogram of the distribution of the sum of 8 dice. And here we have the distribution of the sum of the 10 dice. Now, we can conclude through our developments that we presented the case of a scam which is common in Latin America. We pointed at the reasons for which it's not only immoral but also illegal to perpetrate such theft. And then we took advantage of it to use a spreadsheet program to present the convolution formula and the central limit theorem. The advantage of using the central limit theorem rather than the convolution formula from the algorithm presented is an equation which is given in terms of only 3 parameters, n, mu, and sigma greater than 0. This means that we no longer need to complete distributions of each of the random variables to be added up. Besides, as n grows indefinitely and the algorithm adds only 2 distributions, we would need an infinite amount of time to achieve the results that the other one gives in a snap. Thank you for your attention.
Thanks for watching. Do not forget to click on the like button if you enjoy it and subscribe to this channel and click on the bell so you can get notifications when we upload a new video. Bye!